Welcome to today's webinar, Facebook, Google, Big Switch demonstration of next-gen NOS based on Open Network Linux. My name is Gregg Holzrichter. I'm the Chief Marketing Officer here at Big Switch, and I'll be your host for today's webinar. Joining me is Prashant, Gandhi, my colleague and Chief Product Officer here at Big Switch. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you are watching this video in a rebroadcast or a recording, or you have questions on an upcoming webinar topic that you would like our panelists to address, please email us at info@bigswitch.com. We've also provided you with handouts for today's session. As an agenda item, we're going to be going over some of the topics on how OCP is driving innovations, the anatomy of next-gen network OSs, Open Network Linux, and the ONL Foundation for Next-Gen NOS, Facebook, Google, and Big Switch, and the demonstration that was recently provided at OCP, as well as a summary. All right, so let's get started. So we recently were at the OCP Summit in San Jose last week, and we were inspired by the 3,000 plus attendees and a lot of innovation on show. Over the last 10 years, Facebook and several partners have been highlighting and showcasing sort of the innovations that hyperscalers are inserting into the market. The main focus originally around OCP was around compute. More recently, storage was front and center. And most recently, we've been seeing a real focus now on innovations in networking. So when you look at the components and some of the innovations specifically emerging in the different silos in the data center around OCP, in the compute section, we've seen a large focus on open server hardware, innovations around rack designs, and really making sure that the compute has much more power, much more efficiency, like projects such as Project Cerberus. In terms of storage, we've seen innovations around Project Denali and the disaggregation of flash storage layers. A big focus on NVM Express, and innovations in disaggregation and software definition. And most recently in networking, we see innovations being driven by these hyperscalers and white box hardware providers with this transition from 100 gig to now, the latest 400 gig white boxes being introduces around Sonic, and most specifically, and near and dear to Big Switch's heart, the next gen NOS architecture and ONL, which we'll be talking a lot more about in the remainder of this presentation. And really, we are excited by the focus on networking and believe that this truly is a time of networking renaissance. There is a lot of focus on disaggregation in particular, separating out the industry standard components of hardware, which increasingly is not where innovation and differentiation is occurring, but rather the focus on value add in the software layer, and looking at standardizing on components of your network OS, so that engineering teams and vendors increasingly can focus on differentiation and innovation on the higher levels of this networking stack. And in fact, our colleague Andrew Lerner at Gartner really has stated this best. He says, innovation is being generated and driven into the market by hyperscale web providers, not by the traditional network vendors. While conventional wisdom is that hyperscale networking has no relevance to us regular folks in the enterprise, there is tangible applicability. And we really believe this at Big Switch, and have basically created our company around this concept that an innovator can introduce more differentiation and take these concepts that the hyperscalers like Google and Facebook have introduced into their very advanced, very scalable networks, and take those concepts in off-the-shelf enterprise-class software and deliver that innovation where many of the traditional providers have not been. So we want to actually pause for a second and do a polling question. And the question is, do you believe hyperscale networking innovations apply to enterprise infrastructures? And so please select one of the following. So it'll be interesting, Prashant, to see, the makeup of the hundreds of attendees who believes in the applicability here.
That's right. Yes, I'm curious to learn the results.
All right, overwhelming 72% believe that hyperscale networking innovations do apply. That's fantastic. 28% maybe. So that's even more overwhelming than I would have imagined. That's great. Fantastic. Well, with that, let me hand it over to my colleague Prashant Gandhi.
Okay, perfect. Thank you, Greg. So as the poll results indicated, what we have seen, and this is the bet we have taken at BigSwitch, that we have been really inspired by the innovations in networking that have been happening by the hyperscalers, and we have seen that, or we had always had this intuition that those technologies over time will be packaged into enterprise products, fully supported by vendors, and the proof points that we have seen is really leaf-spine fabrics. Factory design was there way back in the early 2000s, and we have seen cloth fabrics are becoming, leaf-spine fabrics are becoming, pretty standard in almost every data center organizations. We have thousands of customers who have deployed this. So technology inspired and deployed by hyperscalers, adopted by the thousands in the enterprise. Next one is SDN fabrics, right? Google and others have talked about this. ONF has led the initiatives very early part of this decade, and we've seen a variety of SDN fabrics emerge. Certainly our Big Cloud Fabric is one, Cisco ACI is another one, and 1,000+ customers have been, multi-thousands have deployed this in the enterprise. And finally, open hardware. Google Pluto project, kind of the secret switch that was talked about in 2013, and later Facebook's wedge switch. Both of them, bringing the concept of open networking hardware, and then OCP later making that a very standard aspect of the networking track. And we are seeing that there is, nearly a dozen vendors now supporting open networking products, both branded white box vendors as well as ODM white box vendors, including Dell and HPE. And we see that 1,000+ customers have been deploying these solutions. So these have become mainstream. So the question is, what's next? And that's what we will talk about in today's session. And the next is now that the hardware and the NOS have been disaggregated and it is becoming mainstream, customers, very mainstream customers in enterprise, retail, insurance, healthcare, transportation, manufacturing are deploying these products. So now the question is, what's next? And we believe next step is the new definition of the network OS, or the NOS. And so the question is, what is the makeup of the next gen NOS? And the announcement that was made last week at OCP by Facebook, Google, and BigSwitch was to demonstrate multiple NOS architectures in a disaggregated fashion, leveraging common component on the platform side, which we call Platform OS, or Open Network Linux, and OCP open source project, to provide access to many dozens of open networking platforms for these NOSes. And this is really, we can see that taking the next logical step, where a NOS provider has access to multitude of hardware platforms, and a hardware manufacturer, an open networking switch manufacturer, has a choice of variety of network operating systems. And this combination of many to many, we believe, is an important step in disaggregating not hardware software, which was step one, but now disaggregating the network operating system and making it modular. And the step one of that is really modularizing the platform-dependent portion of it, which is Open Network Linux. And so we'll focus, the rest of our presentation focused on this particular aspect of next-gen NOS architecture. Now, if we were to take a step back and look at compute, and one of the things that's kind of quite interesting is that in the 90s, network led the way. We had applications turning to client-server, and the network transitioned to Ethernet and IP, and really led the revolution in what we today see as the internet. And the entire web and cloud revolution has been powered through that transition that happened in the 90s, with network architecture going to Ethernet and IP. But what happened to compute itself? And compute started out as a completely locked-in, monolithic, hardwired across hardware and software architecture. You had a mainframe, you had the minis, you had the workstations. They all followed the same architecture, and the innovation was really locked in, and users had no control, and the price was through the roof. And what happened with the revolution of x86 hardware and the Linux operating system is that not only you had the hardware-software disaggregation, but the OS itself and the apps got disaggregated into very modular and, in many cases, open source architecture, so that the base portion of the infrastructure, computing infrastructure, became very standard and to some extent quite commodity. But one can't say that innovation stopped. Commoditization, standardization does not mean innovation stops. Yes, innovation reduces for the layers where standardization has taken place, and it bubbles up to upper layers of the stack. And so what we have seen is in compute, the innovation rose to upper layers of the stack, where we have seen, hypervisors and virtualization, big data, hyperconverged environment with compute and storage coming together on the server, now also networking, virtual networking, containerization and the big revolution there, cloud infrastructures that we have seen, and now machine learning with a lot of the autonomous way to operate the workflows that we have been used to doing manually. So a lot of innovations occurring despite the fact that there's lower layers of the infrastructure very standard and commodity. What about networking, right? We have, for the past 30 years, since the transition that occurred in the 90s, we have primarily been stuck with this architecture, and one could jokingly call this as mainframe of networking or netframe. And netframe is essentially exactly looks, smells, and tastes like mainframe. It's very monolithic, hardwired, coupled. Innovation is locked in. There's no control, and the pricing is through the roof. And the question is, how do we bring the type of innovation that we have in compute, the speed of innovation, the acceleration, the community, the broad community that is able to innovate? How do we bring those forces into networking? And we believe that the fundamental to this is decoupling of hardware and software, which has taken place, and now disaggregation of the NOS itself, or modularizing it into a variety of components. And one of the fundamental piece of this, the glue code, is the platform-dependent OS, which is Open Network Linux. And this is a code base that Big Switch essentially contributed to and made it open source based on our own SDN solutions. And we have contributed to OCP and are quite happy to support it and bring a variety of hardware and software partners onto Open Network Linux. But once we have this, we can see that the NOS can be disaggregated into Platform OS, which is now standard and open source, and device operations and management, and forwarding. And these are the three canonical components, as we will see, defining the core architecture of next generation NOS. Now, what about innovation? And we are seeing that by disaggregating hardware and software and now bringing ONL as the glue layer for platform-dependent OS, we are seeing that innovation is started to occur in the upper layers of the stack. And not just the fact that we have programming language P4 to program forwarding pipelines as part of Google's Project Stratton, OpenConfig, GNMI. We are seeing the NOS providers from Hyperscale organizations, Facebook's SBOS, Microsoft inspired Sonic are available now as part of the OCP projects. Also the forwarding, BGP stack and L3 protocols are now available as open source as part of FR routing, Quagga, and other projects. So clearly, innovation is not stopping. In fact, the speed of innovation, we believe, accelerates when some of these components become standard and widely available. So, so let's dig deeper into Open Network Linux. What is its purpose and what benefits it provides to end users? So ONL really is a Linux distribution, as its name says, and it is really focused on providing a flexibility and building a broad ecosystem for open networking, specifically open network switches. Each switch, each hardware platform requires, has different ways to define temperature, define speed of fans, power supplies, optics and cables, and variety of hardware mechanisms that are different and from one provider to another, one device to another. And this is a big barrier to, bringing speed in networking, because one is bogged down into supporting all of these umpteen variations and testing them, and it's a huge barrier to entry. And so what Big Switch has done, since we have done this once already for our solutions, Big Cloud Fabric and Big Monitoring Fabric, both are SDN solutions. So we felt that this needs to be done only once and be provided to the community so that we can speed up innovations by enabling more hardware platforms to be available for a network operating system, and for a given hardware provider to have a lot more choices for the NOSes. And so that decoupling is really provided by ONL in a very standard way. So you can customize, upper layers of the stack like forwarding and device operations, but you can collaborate on how to access the fan information, which is really very mundane information that needs to be happening only once in our lifetime. So Big Switch contributed ONL to OCP in 2015, and now we are very excited to see that there is tremendous adoption and traction of ONL, now upwards of 70 platforms and 11 suppliers are supporting ONL, and we believe this ecosystem will continue to grow. So if you need more details, feel free to point your browser to opennetworklinux.org and look at the details. Here is an example really of ONL accessing across multiple devices, open networking devices. Let's say fan information. And you can see the TLVs are very consistent and get the information in the same way, and therefore the NOS now has to write only once and have access to this information across all of these platforms in a very consistent manner. Again, write once and benefit many, many, many times. And this is the ROI that is needed in order to speed up innovations at the upper layers of the stack. So, so our purpose really has been with ONL to accelerate innovation, accelerate adoption of open networking, both across hardware and software. Networking has been stuck in the legacy for the past 20 years. And we are seeing that the innovations that are happening in Hyperscaler, how do we bring that to a broader community? And we believe ONL provides that glue to make that happen. So with ONL, we are engaging on the southbound side and partnering with brite-box and white-box, open networking hardware suppliers. And on the northbound, we are engaging with NOS providers, such as hyperscaler organizations, as well as, showing how open source components such as FR routing can be integrated on top of ONL to provide, next generation NOS architecture, leveraging many open source components. So now let's bring some proof points to as to how this architecture is instantiated across a variety of NOS architectures. So at OCP, there are 3 different NOS environments that have been shown leveraging Open Network Linux and on 100 gig hardware. So Facebook FBOSS on Facebook Wedge 100 gig platform, Big Switch showing BGP fabric leveraging Open Network Linux on 100 gig Edge Core 7712, and Google showing Project Stratum leveraging P4 controller and leveraging P4 programming on a 100 gig brite-box platform, which has not been disclosed. And we'll see a demonstration of this in a little bit. So what's sort of the details of each one of these environments? Let's start with Google's vision for next-gen switch architectures and next-gen SDN. And this is what Google presented at OCP last week, which is leveraging P4 based controllers external to the device and then programming it, having P4 runtime agent on the device, and leveraging Open Network Linux platform APIs to be able to access in a very consistent manner a lot of the platform components, as well as doing asset management and inventory. Google's leveraging ONL as well as OpenConfig in order to bring standards-based components in this next generation architecture. And so the information that they shared is that they had evaluated a variety of open source alternatives, and ONLP, which is ONL platform APIs, provides real hardware extraction as they've stated, and they found that it is very comprehensive, unlike the other alternatives that they investigated. And given the large inventory and the deployments that they have, asset management becomes very important, and that information is important to them. Also, the fact that ONL provides a very structured object model, it allows the client software to be able to learn, Google NOS to be able to learn the structure at runtime, rather than requiring that as a pre-configuration entity. And it's all running standard Linux, which is fantastic. So as Google has been leveraging this, they felt that what their requirements were, ONLP was very, very close to what they wanted. And Big Switch is working closely with Google to support some of the requirements in ONLP, and then bringing it out in the open source world. So very exciting to see that more and more open source components are being brought into next generation architectures, and we see that hyperscalers leveraging these capabilities, and then over time we see opportunity for them to be available to for the benefit of the enterprise organizations. Next is Facebook, and Facebook has FBOSS. They've also announced OpenR, their own routing stack. And if we look at the architecture, it fits in really nicely with FBOSS, OpenR, leveraging ONL and ONLP, running on, for example, Wedge switch hardware. And Facebook shared that they need to run FBOSS not outside of production, in areas such as in labs, in bootstrapping into production, into how they integrate with the vendor and ODM environments. And these are the areas where, and the use cases where they see leveraging FBOSS on ONL as very important, and bringing the speed and flexibility in their environment. And finally, Big Switch demonstrated next-gen NOS architecture leveraging ONL with BGP stack running on top of ONL. So what we have done is, in regards to the device operations, we have built ORCD, or Open Route Cache Daemon, and attached device CLIs to that, and one can extend that to bring APIs as well, and then bringing the routing stack to this, leveraging open source FR routing, running on ONL on 100 gig switch. And we believe that this architecture becomes very important now and quite modern to organizations which often we refer to them as at-scalers, not hyperscalers, but still requiring the benefits that the hyperscalers have. Organizations such as SaaS providers, cloud providers, telco clouds and service provider clouds, as well as some large enterprises who would like to consume these capabilities. And we see this type of concept architecture leveraging, being able to build multi-tier BGP fabrics, leveraging completely open components on open hardware to be a great value proposition for these organizations who demand that they want control, they want speed, and they also want freedom. And they want to innovate on their own terms. They want to be able to add a capability, without really waiting on vendors' roadmap. And we've seen an example of this where a vendor, by simply writing an additional script, is able to get certain types of capabilities that they would have had to wait for 12, 18 months for a vendor to support. So the level of control, speed, freedom, and on-demand innovation is driving innovations in NOS architectures, leading us to this modular environment. Now, what about, the question always comes in open source is, what about production grade? And so I wanted to highlight this here, that open networking hardware is now very standard and widely deployed in production across enterprises, service providers, SaaS organizations, and obviously en masse in hyperscalers. Open Network Linux is production grade. Every piece of code that we ship for our SDN commercial products, a data center switching fabric called Big Cloud Fabric, and a data center network packet broker fabric called Big Monitoring Fabric, or BigMon. Both of them use ONL as its substrate, and therefore for every release, it's fully tested, it's fully qualified on the commercial white box and brite-box platforms that we support. Cables and optics are tested, and if there is a security vulnerability, kernel patches, we support all of that. In order to ensure that production customers have the latest and the greatest. So ONL is production grade, and we've seen FR routing to be production grade. That's deployed in large deployments across enterprise and service providers and SaaS providers and hyperscalers. So really, we're seeing that the stack is becoming hardened, becoming production grade, and this journey is now, the train has left the station. We are on this journey, and the transition to next generation NOS is kind of the next logical step on that journey. For Big Switch, really this journey began several years ago. 2014, when we introduced our product, we started out with open networking hardware, and then in 2015, we recognizing the need to open up the platform-dependent OS, the platform OS, to speed up innovation. We contributed ONL to OCP, and since then, here we are in 2018, where the upper layers of the stacks are now demonstrated for building multi-tier BGP class, leveraging open source components, open source BGP stack, and we can see that the next logical step in this journey is where the entire next-gen NOS is available as a completely modularized, potentially open source, and fully packaged and supported by a vendor. And we see this as kind of the target over the next few years as we transition into the next decade. So let's kind of look at the demonstration of these three different NOS architectures running on ONL and open networking. So we'd like to conduct a poll now. Do you have a 2018 project that could leverage the innovations that were unveiled at OCP last week and the ones that we have talked about? The options are open networking hardware, SDN leaf-spine fabric, open source NOS, all of them, none of them.
Be interesting to see if this one is as overwhelming.
Indeed. Even distribution, indeed. Open networking hardware, 21%. SDN leaf-spine fabric, 16%. Open NOS, open source NOS, 13%. So I would say, half are for one of these projects, and then another 30% for all of them, which is, 2/3 approximately, see the viability of these innovations in their environments, which is fantastic. I think this is demonstrating the fact that the transformation has not just begun, but the transformation is here and ready for adoption. Fantastic. So appreciate your taking the poll. And so let's kind of come back and look at ONL adoption. I need to share the screen, so I will do that since the demo has ended. So we'd like to conduct a poll now. Do you have a 2018 project that could leverage the innovations that were unveiled at OCP last week and the ones that we have talked about? The options are open networking hardware, SDN leaf-spine fabric, open source NOS, all of them, none of them.
Is as overwhelming.
Indeed. Even distribution, indeed. Open networking hardware, 21%. SDN leaf-spine fabric, 16%. Open NOS, open source NOS, 13%. So I would say, half are for one of these projects, and then another 30% for all of them, which is, 2/3 approximately, see the viability of these innovations in their environments, which is fantastic. I think this is demonstrating the fact that the transformation has not just begun, but the transformation is here and ready for adoption. Fantastic. So appreciate your taking the poll. And so let's kind of come back and look at ONL adoption and see where else ONL has been chosen. So we'll start with the hardware platforms. We can see that ONL has now, this is truly very exciting. I mean, 11 open networking switch suppliers, both branded open networking providers as well as white box open networking providers are where ONL is supported. 70 plus open networking switch platforms, all the way from 1 gigabit, 10G, 40 gigabit, and now the latest 25 gig, 100 gig fabric can be built using open networking hardware. And all of these are leveraging ONL. We have also implemented a certification program. Our hardware vendors are highlighting the fact that given the broad engagement with the community, that we need to have a formal process for certification, and which Big Switch announced last week at OCP. And we are very excited to announce 4 suppliers of open networking hardware: HPE, EdgeCore, Quanta Cloud Technologies, and Delta Networking are certified gold, have certified gold platforms And the key purpose of gold certification is to really continuously test newer ONL versions so that end users have the confidence that as they're consuming NOS architectures based on ONL, that the latest and greatest versions of ONL are fully validated on certified gold platforms. Now, what about upper layers of the stack? Certainly, as I mentioned earlier, both of Big Switch's products, Big Monitoring Fabric and Big Cloud Fabric, are SDN fabric solutions, leverage ONL from the get-go, from day one. So ONL is very, very hardened for these supported open networking hardware platforms by our commercial products. We saw a demonstration of FBOSS and Google Project Stratum leveraging those NOS stacks on ONL. Project Cord, the telco central office stack, is also leveraging ONL for supporting open networking white boxes. Project Stratum, which was announced earlier this month, which is really next-gen SDN platform that Google demonstrated, is leveraging ONL. And NTT's BGP Go project, which is a specialized routing agent for EVPN, has demonstrated leveraging ONL on open networking platform. And this week at ONS, Open Networking Summit, Cisco also demonstrated iOS XR on white box switch, leveraging ONL and ONLP. So we see that the promise of ONL, which is a choice of NOS to open networking hardware, and a choice of open networking hardware to a given NOS, is coming to fruition. It has become a reality. And this allows us to now bring innovations at the upper layers of the networking stack, which are sorely needed, and kind of catch up and become a first-class citizen with innovations that are occurring in compute and storage. And this journey is not something that has recently happened. This has been happening over the last 5 years, ever since the launch of Open Compute Project and the availability of OCP reference networking hardware. And we have seen the evolution since then, which is ONI for open network, open source boot environment for switches, ONL, a variety of other stacks and hardware that have come about to today, where open networking is kind of the talk of the town. And ONL has tremendous traction across so many of these initiatives. Essentially, it has become the de facto go-to platform code for a multitude of these projects. And given the breadth of hardware that is available with ONL, it's kind of a no-brainer to now innovate NOS architectures and upper layers of the stack, controllers, orchestrators, analytics engines, all of that on top of this open modular environment. So I would kind of summarize that ONL has become foundation for next-gen network OS architectures. It is production grade. Wanted to stress that again because it is leveraged through our commercial products, and it's deployed in hundreds of large data centers across enterprises, service providers, SaaS organizations, cloud organizations, and so it is ready for mass adoption. And so we earlier kind of started out having the premise that hyperscaler technologies over time then percolates into at-scalers, SaaS organizations, service providers, early adopter enterprises, and cloud organizations. And they are the ones who disaggregate and consume and integrate in their own environment. And then later on, vendors such as ourselves and others who then aggregate the entire stack for enterprises. And we saw these examples of leaf-spine cloths, SDN fabrics, open hardware to be taking place over the past few years. And here we are today, now seeing next logical step in the journey, introducing or discussing next-gen network operating system, which is at the initial stage, the first stage of its unveiling, and we would expect that as we take this journey over the next few years, that it will move from hyperscaler organization to at-scalers, and we are already seeing that. Our survey already demonstrated that, and then a little later, reaggregated by vendors for enterprise consumption. So I believe these are exciting times for networking. I feel like those of us who were in the 90s and kind of had the Kool-Aid and the excitement of network transformation from very static TDM to Ethernet and IP, I believe that there is a similar type of wind is blowing, wind of innovation that will bring this next level of transformation in networking. So with that, we are going to end our presentation portion of the webinar, and we will go into Q&A.
Great, thanks so much, Prashant. So we are looking at Q&A, and I encourage folks, if you do have questions, to go to the Q&A box and insert your question there so we can pick those up. The first question is, can you describe the relationship of ONL and Big Switch's commercial solutions?
Absolutely. So Big Switch commercial solutions are SDN fabric solutions, one for data center switching and the other one for data center monitoring. And so they're controller-based. There is a lightweight switch operating system that is resident on each of the open networking switch, which is completely controlled and managed by the external SDN controller. And we call that resident lightweight OS, SwitchLite OS. And the SwitchLite OS is built using exactly the same principle that we talked about of modularity. It leverages Open Network Linux as the substrate for platform-dependent code. And then it has a shim layer, which allows us to manage the box and program it using external SDN controller, so that the entire fabric, leaf-spine fabric of 140 plus switches appear as if it's a highly available, resilient, logical switch. So it is for every release of big monitoring fabric and big cloud fabric, ONL is tested, validated, any security vulnerabilities are there, it is patched and available for production.
Great, okay, that's helpful. And let's see, let's take a look here. There's a question around the relationship between FRR as a fork of Quagga. Do you want to take that one?
Yeah, FRR is an open source project, and it has been forked off of Quagga, and a variety of NOS providers, ourselves included, leverage FRR for BGP routing and other routing stacks, and it's broadly deployed in large scale production enterprise service provider environment, SaaS environments.
Great, okay, and then it looks like what do you see as the main challenge for Open Network Linux right now?
I would say rather than challenge, really, ability, if NOS providers or folks who want to, customize network operating systems, if they just try out ONL, it would, they would see the benefits immediately. And so I think the challenge is really getting the word out so that more people can adopt it. Oftentimes in open source projects, the challenges are, in terms of how do I compile it? Does it have enough capability for it to work in my environment? How much customization do I need to do? And what we have seen working with hyperscalers and others in our own environment, that ONL is ready for prime time consumption. So it's a matter of really the challenge is how do we get the word out and have a broader community kind of try it out and test it.
Yeah, and a follow-on question there. I think that there was a question on the number of hardware platforms that are adopting ONL. Could you comment on that?
For any a glue code like ONL, it is super important that there is broad availability of platforms, and I think to me that is really a huge value. In effect, if we highlight two core values of ONL, one is the breadth of hardware across all speeds from 1 gigabit to 100 gigabit, and we recently announced our support for edge core's 400 gig switch to bring ONL to 400 gig platforms. So those environments, high-end environments where folks are going to be looking at 100 gig, 400 gig fabrics, ONL will be available for that. So that breadth and the speed at which ONL is available to broader and broader set of platforms is very important and very valuable. So I think that's one of the two core values. The second core value is the standardization of the platform APIs in order for it to be able to have a very consistent access by the NOS architectures. And this we saw, across the variety of the NOS environments. If you want to look at temperature or fan speed or status of the power supply, do inventory for asset management, you want to do this only once across a variety of platforms that you can support. And that really provides the choice. For this pod, I can choose, vendor one. For another pod, I can have a totally different box for the specific use case of that architecture. And that flexibility, without changing my NOS environment, without customizing it, hardwiring it. And so having that standard platform API becomes super critical. So I see these two components that ONL provides are really core to its adoption, and we are seeing that the adoption is kind of accelerating given these two components.
Fantastic. No, that's great. And I think that there was another question, which is sort of the relationship that you commented about ONL versus our commercial solutions. And I think what this is really highlighting is ONL as a enabler for these hyperscale type concepts to be deployed across many different types of hardware platforms. But it's a building block, and while free and open sourced, the commercial solution that we have uses it as a component, and the innovation and the off-the-shelf sort of bespoke nature of the commercial solutions is quite distinct. It's kind of using this as part of our SwitchLite OS, managed by our centralized SDN controllers, and so quite different.
Absolutely, it's not a piece of code that's just open source, put on GitHub, and then here it is, and do what you want to do with it. And it's not like that. It is really, we want to make sure that this code base is the driver to the innovation engine for networking, and for that we are doing a lot of heavy lifting. A lot of investment on our end is going in to support ONL, so that it remains production grade and it is consumable rapidly by all of our partners, both on the hardware side as well as on the NOS side. I would also mention that as part of this, we do for those organizations that require customization and those that would like extensions to be added to ONL for their specific needs, we work with them, and we provide that development support to them as part of our engagement in ONL, and we see this sort of as more and more ONL adoption takes place. We expect more and more customization to occur, and as that customization occurs, and that customization is then recontributed back to the open source community, it becomes it's a domino effect. Now as we iron out all the rough edges, it is more and more applicable to the wider community. So it's a very nice constructive feedback loop. It's not just that we are doing it for our products and then saying use it, even though it is production grade, it may not meet your need, environment, in which case we work with our partners and customize ONL for their needs.
Great. So it looks like a couple of additional questions here. As it relates to domain-driven application orchestration for deployment with inclusion of the network layer in a declarative way, i.e. YAML, are the APIs to these different stacks standardized?
I think that's a great question. I believe that's an area that's super important. One, I would say, an important step in that direction is what is happening with Project Stratum and leveraging, models such as OpenConfig that allows, standard way to interact. Programming languages that allow standard way to interact with the silicon. So I think these initiatives are also here, and it's a matter of time before they become broadly accepted.
Great. Okay, and then another question of so is Big Switch working to support large port capacity chassis switches with either ONL or Switchlight OS?
Yeah, that's a great question, and I think we always look for a use case and a design partner, and so if one looks at Big Switch's SDN architecture, it is in fact a logical chassis, despite the fact that it is built using pizza box switches. Effectively, it is a logical chassis, so it is quite natural for ONL to be extended quickly to chassis architectures. And the question is, how do we bring that, with the need of the user or the end user? And so if you have these specific needs, we would love to collaborate with you and bring about that extension of ONL to chassis architectures.
Fantastic, and we're kind of wrapping up here in terms of questions, but here's one more. What do you see as a difference between ONL and OPX, OpenSwitch, which is another Linux-based OS?
Yeah, it's really the approach with ONL is to broaden the platform-dependent OS across a large set of platforms. So from that perspective, really, ONL provides users with access to large set of hardware platforms, and we see the innovations occurring in a variety of dimensions, and it then really focuses on what each of the users' needs are, and then they are able to pick the specific platform that best suits their needs. And we have seen with ONL and the NOS and the hardware partners that the value that it provides is really for the use cases of these organizations.
Fantastic. Great. Well, that basically comes to the end of our time. I wanted to thank everybody who's attended and also encourage you to go and visit our BSN Labs online environment. You can point your browser to labs.bigswitch.com. We have over 10 live modules, each their own Ravello instance, so you can actually spin up an environment and get the look and feel of what it's like to manage cloud native networking in a very next generation way. And that's both with the commercial monitoring solution as well as our integration with VMware or OpenStack and a lot of interest in container networking. So I encourage you to go and visit BSN Labs. We also have a free community edition if you have an on-site lab environment with hardware that meets our HCL. So that would be both Acton as well as Dell and HPE solutions or switches. And in terms of upcoming webinars, we have a webinar around how software-defined networking can simplify scale-out hyper-converged systems, and that will be hosted by Storage Switzerland, which is a third-party analyst firm, and that's scheduled for April 4th. We're getting a lot of interest in shops that are deploying, vSAN, Nutanix, Scale.io, as well as SimpliVity. And while a lot of these hyperconverged solutions have focused on storage and servers, networking has been sort of an afterthought. And as many of these clusters are starting to scale out, networking is increasingly becoming a very important component of these scale-out hyperconverged clusters. So we encourage you to, if you're looking at hyperconvergence at all, we encourage you to join and understand how we can bring the networking easy button to your networking and hyperconverged. We also have a SDX Central webinar that will be scheduled for April 17th, and that's going to be focusing on next generation data center findings in the survey and report that SDX just wrote up, and that will be published next week. And a lot of interesting findings and relevant concepts around concepts that the hyperscalers have deployed in their production networks, and now that we're seeing interest from mainline enterprises to actually deploy and get those sort of order of magnitude management benefits of managing networks using modern SDN concepts as opposed to box by box old school networking. So a couple of pretty important and interesting topics that I encourage you to join us for. We also will be sending links for a repeat of this particular webinar, as well as resources and the downloaded slides to everybody on the call. For those that did ask questions that we didn't have a chance to answer, we will send you personal emails with responses for all of those questions. And with that, I wanted to thank Prashant for your presentation and all of you for joining us. It really is a renaissance in networking, and we are excited to be in the forefront of bringing change to organizations like yours. Thanks a lot for your time.